Now let's take on some examples, applications of normal distributions. So here we have a problem that reads, assume that adults have IQ scores that are randomly distributed with a mean of 100 and a standard deviation of 15. Find the probability that a randomly selected adult has an IQ greater than 131.5. The requirement for the Mensa organization. So first of all, note that our random variable x follows the normal distribution with a mean of 100 and the standard deviation that equals 15. So that's important. And which probability are we looking for? We're looking for the probability that x is going to be greater than 131.5. Again, I'm going to use our StuckCrunch to solve this problem. Here we are. The mean of my distribution is 100. And the standard deviation is 15. I'm looking for the probability that x is greater than 131.5. And that probability is 0.0179, rounded to 4 decimals. Now that tells me that there is more than less than 2% of people that has an IQ score that's greater than that value. Okay, the next question reads, find the probability that a randomly selected adult has an IQ between 110 and 120, referred to as bright normal. So we're going to switch to between. And for the x values, we're given 110 and 120. And the probability of that, probability that x is between 110 and 120 is going to be 0.1613. So again, about 16% of the population has this IQ. So what is that value of 0.1613 that we just found? How do we interpret it? And please pay attention to this piece of information. It says, if a certain population follows a normal distribution with parameters mu and sigma, and if we let x be randomly selected observation from such population, the probability of x being between A and B can be interpreted in the following two ways. It is the probability that the randomly selected value is between A and B. Remember, we talked about it earlier. Probability is the same as area under the curve. Or number two, the proportion of the population that has a value between A and B. So the area under the curve is the same as the probability is the same as the proportion. Similarly, the probability that x is less than c can be interpreted in the following two ways. The probability that a randomly selected value is less than c, and the probability of the population proportion that has a value less than c. Okay, so again, we mentioned that already, so now we just formalized it.